All right, let's dive right in. Today we're getting back to the absolute basics. We're talking about the science that explains pretty much everything you can touch, see, or feel. We're going to build a really simple but super powerful toolkit by looking at three core ideas: what stuff is, how we describe it, and finally, how we measure it.
I mean, think about it for a second. It seems so simple, right? You've got ice, it's melting, the water's getting cold, but what's actually going on there, at a level you can't even see? Why does it happen that way? What are the rules that make that happen? Turns out, that one simple glass holds the keys to understanding our entire physical world.
So how do we answer those questions? Well, that's where chemistry comes in. And look, you might be picturing labs and crazy bubbling beakers, but at its heart, chemistry is really just the science of stuff. All the material that makes up our universe.
Now, if we look at the official definition, you can see chemistry is kind of like a three-part mission. First, it's about understanding the properties of matter, what something is like. Second, it's about understanding the changes it can go through, what it can become. And third, it's about figuring out the fundamental rules that control everything.
Okay, so before we can even begin to understand those big, sweeping changes, we first need a way to just describe matter. Think about it, like you're meeting someone new. You notice things, right? Their height, what they're wearing, you're just gathering data. Well, in chemistry, we call those details properties.
And these properties basically fall into two big groups. Now, the best way I've ever heard it explained is with this analogy. Physical properties are like a substance's outward appearance, while chemical properties, well, that's more like its inner personality.
And here's the real difference. A physical property is something you can observe or measure without actually changing what the substance is. You can find the weight of an apple, and guess what? It's still an apple. But a chemical property, that describes its potential to become something totally new. To see that personality, the apple has to change, like when it turns brown because it's reacting with the air.
So let's circle back to our glass of water. The mass of that ice cube, the volume of water it takes up, its density, which, by the way, is why it floats, and the exact temperature where it melts, all of those are physical properties. We can measure every single one of them, and we still just have H2O.
Okay, so we know we have to measure all these properties. But how do we make sure that a measurement I take right here means the exact same thing to a scientist halfway across the world? We need some kind of shared language.
And that's exactly what a unit is. It's just an agreed-upon standard that we all use. When I say a kilogram, or a liter, or a degree Celsius, you know exactly what I'm talking about, because we've all agreed on what those things mean. It is the absolute bedrock of scientific communication. I love thinking about it this way. A discovery that doesn't have units, it's really just a story. It's an anecdote. But a discovery with units, now that's data. That's real knowledge that can be shared and tested and built on by anyone anywhere on the planet. It's what turns one person's observation into humankind's collective knowledge. So, we've actually covered a lot of ground here pretty quickly. Let's pull it all together and pack it up into your own personal chemist's toolkit. It's really just built on three core ideas that all fit together perfectly. Here it is, the whole logical flow, step by step. Number one, chemistry is the study of matter, all the stuff in the universe. Number two, we figure out that all this stuff has properties, its appearance and its personality. And number three, to actually describe those properties in a meaningful way, we use a shared universal language of units. See? It's that simple and that powerful. So now you've got it. You have the fundamental framework that every single chemist uses to understand the world. So the next time you see bread toasting, or an egg frying, or even just ice melting in a glass, you can start to ask, what matter am I looking at? What are its properties, and how is it changing? Go on, what will you explain first?